Hello guys, welcome back to this amazing lesson. In this lesson, we'll be discussing Introduction to TensorFlow Basic Deep Learning Framework. In modern machine learning and artificial intelligence, the ability to build, train, and deploy deep learning models efficiently is critical. TensorFlow is one of the most powerful and widely used framework that enable us to actually do that. In this lesson, we will understand what TensorFlow is, why it exists, how it works internally, and how to use it to build real deep learning models. By the end of this lesson, we will be able to use it practically. Now, before we proceed, let's actually see what this TensorFlow is. Now, we said TensorFlow is an open source machine learning and deep learning framework developed by Google that allows developers to build, train, evaluate, and deploy machine learning model efficiently. Now, we said the word tensor is a what? A multidimensional data structure, that is number arranged in array. While flow, it actually means the what? The movement of data through a sequence of mathematical operation. So TensorFlow actually means what? The flow of tensor through a computational graph. Now, let me give a scenario of what I'm actually talking about the what TensorFlow now. Now, TensorFlow is like a engine behind the modern AI system. It handles the mathematics, the optimization, and the what? The hardware acceleration. So we actually focus on what? On designing the intelligent model instead of the manually implementing complex what? Equation. Now, let me bring my cursor down a bit now. Now let's continue. Why do we use what TensorFlow? Why it actually exists now? 1. Scalability. 2. Flexibility. 3. Strong ecosystem. 4. Large community. Now when it comes to this scalability, now it runs on laptops, servers, and what? Cloud platforms. Now in the case of the flexibility, now it actually supports what? Research and production environment. Now when it comes to the strong ecosystem, now it integrates with what? Keras, TensorFlow Lite, and what? And TensorFlow Serving. Now in the case of the community, now it has a very large community now. So that's actually what? Extensive documentation and what? And community support. Now let me give a scenario of that now. Now before TensorFlow, now researchers had to write large amount of low level what? Mathematics code. So TensorFlow abstracts that complexity, making deep learning faster, scalable, and what? Production ready. Now the next, take this core concept one after the other now. 1. Tensor. Now like I said earlier, a tensor is the fundamental data structure in what? In TensorFlow. So they are what? Multi-dimensional array and the core data structure in what? In TensorFlow. Now the type of the TensorFlow, then the type of the tensor that we have now, we have the scalar, we have the what? The vector, the matrix, the higher order what? Tensor. Now, so when it comes to the scalar now, so based on dimension, it has 0 dimension. Now example of it is 5. When it comes to vector, now it has 1 dimension. So examples of it is what? 1, 2, and 3, and so on. So y matrix is what? So it has 2 dimensions. This is an example of how the dimension actually looks like now: 1, 2, 3, 4, and so on. So higher order what? Tensor now. So it has 3 or more what? Dimensions. So like images, videos, and so on. Now, so everything in what? In TensorFlow now flows as a what? As a tensor. So data, when it comes to the data, weight, gradient, and what? And output. Now the next one we'll be looking at is what? Is the computational what? Graph. Now TensorFlow now represents computational as what? As graph. Now in 2 ways now, either the nodes or the what? Or the edge. Now the node now, there's the mathematical operation, while the edge is now is what? Is the data, that means tensor. So flowing between what? Operations between the nodes now. So this makes TensorFlow efficient and actually what? Scalable. Now what I'm trying to say there is that this graph based what? Approach now allows TensorFlow to optimize performance and what? And parallel execution. Now let me bring my cursor down now. Now the next one is the what? Is the Keras API. Now Keras is the TensorFlow's high level API that makes building neural what? Network easier and what? Faster. One of the benefits of it is what? Simple syntax, faster model development, ideal for what, for beginner. Now, in case of this what Keras what API now, Keras allows us to what, to build deep learning models in just a few lines while what, maintaining full what, flexibility. Now, the next thing we'll look at is what is the TensorFlow workflow. Now, a typical TensorFlow workflow includes what, import TensorFlow, prepare data, build a model, compile the model, train the model, and evaluate and make what, prediction. Now, what I'm trying to say there is that every TensorFlow project now follows this what, life cycle now, whether it is a simple what, regression or a large scale AI what, system. Now, TensorFlow architecture now, from the input data to what, tensor creation. Now, after we create our tensor now, so to neural what, network layers, from there to the what, loss function, from there to the optimizer. Now, that's the gradient. This is the what, the TensorFlow architecture now, from the input data to tensor creation, from the tensor creation or tensor operation now to neural what, network what, layers, from there to the loss function to the optimizer. Now, that's the gradient descent. Now, from there to the updated what, weight or updated model. Now, with this architecture now, TensorFlow connects data flow along with what, computation, optimization, and hardware acceleration into one what, seamless what, pipeline. What application of this TensorFlow now? One, image recognition like Face ID, speech recognition, recommendation system, fraud detection, autonomous what, vehicles, chatbot, and AI what, assistants. Now, let's actually see some practical works on how this what, TensorFlow actually work. Now, the first thing to do is to install our TensorFlow now. If you are actually making use of Python now, so kindly follow this procedure now. So to install it now, in your Jupyter notebook, you just come out and say what, exclamation pipe install what, TensorFlow equals what, 2.15 what, point 0. Now, this version is actually very more stable now, so it actually supports what, Python 3.11. So, and what, Python, let's say 3.11 point what, point 3, and so on. So it also supports the 3.10 also. So there's different ways at which we can actually install this what, TensorFlow now, like Python 3.10 now. So you can just say what, pipe install what, TensorFlow, without putting the version that you actually want now. So it will actually work, but in some cases now, so it may give you error now, whereby the word, the Keras what, may not work perfectly well. So in that case now, so just state this what version there now and what, and install it, so it is very much stable. And also, if you are making use of your what, Anaconda now, just come out in your what, Jupyter notebook and say what, conda install what, TensorFlow equals what, version 215 point what, point 0. It will work perfectly well. Now let me bring my cursor down now, so, and it will install all the packages that is actually needed. So you can see it now, it will indicate a warning, and also requirement already was satisfied, so it's now what's been installed. So let's actually check the version of it now, and let's continue. Now, to see the version now, I will now come here, I will now say import TensorFlow as what, as TF. Now I'll run this now, I'll hit on enter, I'll now say print. Now open parenthesis TF, now dot underscore what, underscore version. Now twice, I'll now say version, now underscore twice again. I'll close this parenthesis, I will now run this, control enter. So let's wait for it to come up now. Now I'll bring my cursor down now, let's actually see it now. So let's ignore the warning. So the version that we actually installed was what, 2.15 point what, point 0. So let's continue. Now the first thing we'll be doing now, we want to see what, tensor what, creation and basic operation. Now to do that now, so we want to actually understand how tensor actually what, behave. First thing we'll be doing is that we want to actually what, do some creation and see how what. Now the first thing we'll be doing, we want to actually see the what, the creation of this tensor, and also the understanding of this what, this tensor. Now that means what I'm trying to say is that tensor are the fundamental what, building blocks in what, in TensorFlow. flow. Now let's actually see how it actually works. Now the first thing I will be doing, I will now say import TensorFlow. TensorFlow as what? As TF. Now I'll hit on enter. I will now bring up my what? My Scala. So that Scala is under what? Tensor. Don't forget, based on what we treated earlier, that will now be TF dot what? Dot constant. Dot constant. Open parenthesis. Now let's say 5. Close this parenthesis. Hit on enter. I'll bring up the vector. Now equals what? TF. Now dot what? Constant. Now open this parenthesis, open this list. Now 1 comma what? Let's say 1 comma 2 comma 3. Now close this list, close this parenthesis. I'll hit on enter. I'll bring up the matrix. Now equals what? TF. Now dot what? Dot constant. Dot constant. Open this parenthesis, bring up this list. I'll now say 1 comma 2. Now comma 2. Now close this list, close this what? Put a comma, bring up another list. Now I will now say 3 comma 4. Now close these two lists. Now which is the one for this and one for the first one we actually opened here. I will now close this what? This first parenthesis. Now I will now print them one after the other. To print, I will now say print. Now open parenthesis, Scala first. Scala. Now close this, hit on enter, print. For the next one, now that's the vector. Now close this parenthesis, hit on enter. The next one now be what? Matrix. Now open parenthesis, matrix. Now close parenthesis. Now I will now run them. Now control enter. So you can see them now. So this is what we actually print. So this is the shape and the data type. Now that's for the what? That's for the Scala. Now for the matrix, for the vector now. So this is it now. And for the matrix now, this is it. Now, like we said earlier, now we said Scala is a single value. So that's why we actually make use of a single value, and it actually returns a what? A single value. Vector is one what? Dimension. So this is a single dimension now. So that's why we have a what? A single dimension and what? 3 shape. And for the matrix now, it's what? It is 2 dimensions. This is first dimension, the second dimension. So it has what? 2 different, and this is the shape of it now. Now, like we said earlier, now you can see now the Scala is what? A single what? A single value. Now the vector is what? 1 dimension. That's the 1 dimension that we have here. And the what? And the matrix is what? Is 2 dimension. You can see we have what? 2 dimension. And these are their what? These are their shapes now. So all this data in TensorFlow now flows as what? As tensor. Now, so another thing is, if you actually understand what tensor now, so you understand what TensorFlow. Now the reason is that everything from data to the weight now is represented as what? As tensor. Now the next thing we'll look at is what? Is tensor operation. Let me actually bring it up here now. Tensor operation. Now, so mathematics, let me say mathematics or math without what? Loops. Now close this. Now let's turn this to what? Markdown. Let's run this, control enter. So let's continue. Now in this, now TensorFlow now perform what? Vectorize what? Operation efficiently. So let's actually see it now. So the first thing I'll be doing, I'll now say A equals what? TF. That's for the TensorFlow dot what? Dot constant. Now I'll open this parenthesis, I'll bring up this list. I'll now say, let's say 10 comma 20 comma 30. Now I'll close this parenthesis and I'll close this. I'll hit on enter. That's for A. Now for B, now I'll now say equals what? Equals TF. Now dot what? Dot constant. Now open this parenthesis. I'll now bring up this list. I'll now say 1 comma what? 2 comma what? Comma 3. Now I'll close this list now. I'll close this parenthesis. Now the first thing I want to do now, this is our A and this is our what, our B. So I want to add and I want to multiply. To add now, I will now say add equals what, A now plus B. That's for the add. For the multiply now, I'll say multiply equals what, A now shift 8 now B. That's for the multiply. Now I will now print. Now print open parenthesis add close parenthesis control enter. So we've actually what, do the addition now. So that will be 10 plus 1, that will be 11. 10 plus 2, 20 plus 2, that's what, 22. And what, 30 plus 3, that's what, 33. So this is the shape now. So the shape is 3. Now the next one, now let's actually what, multiply. Now print open parenthesis multiply close parenthesis control enter. So you can see it now. 10 multiplied by 1 is 1, 20 multiplied by 2 is 40, and 30 multiplied by 3 is what, is 90. So this is the data type and this is the shape of it now. So you can see now the operation happens what, element what, wise. So no manual loop is actually what's needed, and optimize internally for what, for speed. So what I'm trying to say is that this is why TensorFlow is very fast. So you write a simple math and TensorFlow and do the what, the heavy what, lifting. Now let's still see another example under it. Now let me bring my cursor down. Now another example. Now let me just bring my cursor down a bit. Now let's come here, let's print, let's say print. Now open parenthesis tf now dot what, dot constant. Now open parenthesis, open this list. I'll now say what, let's say 1 comma 2 comma 3. Now close this list, close this parenthesis. I'll now say plus. I want to add plus what, tf dot what, dot constant again, dot constant. Now open this parenthesis. I'll bring up this list again. Let me say 4 comma 5 comma what, comma 6. Now close this list. So I'll now close this what, this first parenthesis here that we opened here. Now I'll close it. I'll now close this parenthesis that we opened here now last. So I will now run this now, control enter. So you can see it now. So it has actually summed it up now. 1 plus 4 is 5, 2 plus 5 is what, 7, 3 plus 6 is what, is 9. And this is the shape of it and the data type. Now let's see another example how we can what, determine what, the shape, the rank, and the data type. Now I'll now say tensor equals what, tf now dot constant. Open this parenthesis, bring up these two lists. I'll now say 1 comma 2 comma what, comma 3. Close this list. Now put a comma. I'll now bring up this list again. Now 4 comma what, comma 5 comma 6. Now close this list. Now I'll now close this what, this first list now that we opened here. Now I'll close it. I'll close this parenthesis that we opened here. Now I will now hit on enter. I will now print. Now print. What am I printing first? Now double quotes. Now say shape. Now double column, close double quotes. Now I'll put a comma. I'll now say tensor now dot what, dot shape. Now close this parenthesis. So it will bring up the shape for us. Now control enter. So you can see the shape. Now the next thing I want to print is what, is the rank. I'll hit on enter. I'll now say print open parenthesis double quote. I'll now say rank. Now I will now say double column, close double quotes. Now I'll put a comma. I'll now say tf now dot what, dot rank. Now open parenthesis. I'll now say dot rank. I'll now say tensor. Now tensor, close these two parentheses. Now I'll run this, control enter. So you can see it now. So this is the rank of it now. The next one, now let's see the data type. I'll now say print. Now open parenthesis double quote. I'll now say data. Now data type. Now I'll now see double column, close double quote. Let me just undo and let me come here. Now close double quote. Now I'll put a comma. Now say tensor dot what dot d type. Now I'll close this parenthesis. I'll run this, control enter. So this is the data type of what? Variables and trainable parameters. Now let me actually come here and state it here. Now let me change this to markdown. Now let's continue. So I will now come up, let's say weight equals what? TF. Now that's TensorFlow dot what dot variable. Now open parenthesis 2.0, let's say 2.0, close this parenthesis, hit on enter. For bias now, and now say bias now equals what? Now TF now dot what dot variable open parenthesis 1.0. Now close parenthesis. Now I'll hit on enter. Now come here, now say s equals what? Equals TF now dot what dot constant. Now open parenthesis, now 3.0, close parenthesis, hit on enter. For y now, let's say y equals what? Weight. Now weight multiplied by x. Now plus what? Bias. Now I will now let me bring my cursor down so that we can see everything very well. So I'll hit on enter. I will now print y now. Print open parenthesis y, close parenthesis, control enter. So you can see now this is the TensorFlow of it now. Now this tf dot what dot variable now it actually represents what? The trainable parameters now used for the what? For the weight and the biases now. So can be updated during what? Optimization. So whenever a model learn now, it is adjusting variables, not the what? Not the constant. Now let's see another example. Now let's say x equals what? Cos tf now dot what dot constant. Now open parenthesis 10. Now close this parenthesis. That's our x now. And for y now, let's say y equals now just like it was a simple equation. Now let's say x plus what? Plus now x plus 5. Now this is our x now. Now x plus 5, that's what y equals now. So we'll now print for y now. Print our y now. Now say print open parenthesis y. Now close this parenthesis now. So it will give us 15. Control enter. So you can see now the TensorFlow dot tensor now is what? Is 15. This is the shape and this is the data type. Now one thing about this TensorFlow is that TensorFlow runs in what? In eager execution what? Mode by default now. So this actually means what? Operation executes immediately, just like what? A normal Python code now. This makes our what? Debugging and what? Learning much easier. Now before we continue, let me move my cursor up now. I want to emphasize on something. Now what we actually did here, now we actually see the word tensor shape, tensor rank, and what? And data type. That's what we actually did here now. So now let me emphasize more on this now before we actually continue. Now before we actually train any model now, TensorFlow must actually understand the structure of our what? Of our data. Now the shape will tell us the what? The size of each of the what? Of the dimension that we actually have in our what? In our data. Now and the rank will tell us how many dimension actually what exist. That's what this rank will actually does. So this rank is telling us what? 2 dimension actually what exist. And for the data type now, it will define how the values are stored in what? In the memory. So that is what the data type actually does. Now you can see it now. This is telling us that what is actually stored as what? Integer 32. So you can see it now. So take note of that. Let's continue now. Now the next thing we look at now, let's actually see what automatic type what conversion. So let me just come here and name it here now. Let's say automatic auto automatic type conversion. Now let me change this to in markdown. Now let me bring my cursor down. So let me hit on more cells. So let's continue. Now what this actually does is that it shows what how TensorFlow handle different what numeric type what safely. Now let's actually what see it an example under it now. Let's say x equals what x equals tf now dot constant. Let's open this parenthesis, bring up a list now 1 comma 2 comma 3. Now so close this list, put a comma. So what we are actually doing now, we are here to be using a data set now, so that when we started using a data set, we will be very what conversant with it. Now let's say data type now equals what tf dot what dot integer now integer 32. Now close this parenthesis now. So I will now hit on enter. For the y now, y equals what tf now dot what dot constant. Now open this parenthesis, bring up this list. I'll now say 1.5 now comma now 2.5 comma 3.5. I want to use decimal this time around. Now let me just give a space here, come here, close this this list. Now put a comma and now say d type now equals what tf now dot what dot float now float 32. Close this parenthesis. Now next thing now say z equals what now tf dot, I want to cast it now, cast. Why am I casting? Open parenthesis the x comma now tf now dot what dot float now float 32. Close parenthesis. Now plus y. Now hit on enter. I'll now print now open parenthesis z now close parenthesis. Now let's print this z now. So this is what we actually want to cast now. Control enter. So you can see now we've actually casted what this now. Now let me emphasize on it now. TensorFlow is very strict when it comes to what data type now. So when mixing what integer and what and float, this is float and this is a what this is integer now. So we must explicitly what cast the values now. So this will ensures what numeric stability, especially when we are actually dealing with what deep learning what models now. So that explicit what casting avoid what silent calculation errors for us. Now let me show us something. Let me move my what a cell up now. Let me just move it up. Let's move this up again. Now let me see, let me scroll up now. So let's continue. So I want to show us one more example under this word variable and trainable parameters now. That means variable and constant. Now let's see this example now. Let's say w, that's for the weight now, equals what now tf dot what dot variable open parenthesis. Now let's say 2.0. now close this, hit on enter. For let's say b, that's for the bias now, equals what now tf now dot what dot variable again dot variable open parenthesis 1.0 close parenthesis. Now let's hit on enter and come in. Let's say y equals what now w now shift 8 now 3 plus what plus the bias now. So let's see, let's print this now. Print open parenthesis. What are we printing? The y. Now close this parenthesis. Let's see what we have. Control enter. So you can see it now. We still got back what? We still got back this. Now you can see now what we did here is actually what? The same thing now. So now this constant now it actually hold what? Fixed values, but variable represents what? The parameters. Now this variable now it actually represents what? Parameters that can change, that can actually what? Change. So in machine learning now, weight and biases now are stored as what? As variable, because they are what? They are learned during what? During training. Now take note of this now. It's only variable that actually learn. So constant doesn't what? Doesn't learn. Now I want to show us another example under this what? Mathematical what? Function now. So that's why I bring up this what? This cell again. Now another thing is that this what? Mathematical function now it actually demonstrates what? TensorFlow as what? As a numerical computing what? Engine. Now it can actually comes in different way. That's why I'm trying to what? Bring up different examples now. So let's say now x equals what? Now TensorFlow now dot constant now open parenthesis. Now let's say 4.0. Now close this. Now hit on enter and come here. Let's say y equals what? tf. Now dot what? Dot square. Now dot square open parenthesis x close this parenthesis. Let's say plus. Now 2. Now multiply by what? Now x. Now plus, let's say s plus 1. Now so let's print our y now to get the value of y. So this is all this now equals what? Y. Now we'll now say y close this parenthesis. Now control enter. So you can see it now. So x is what? 4.0. Now 4 plus 2 now multiply by what? 4 plus 2 multiply by 4 plus 1. Now you can see it now. So this TensorFlow now allows us to express mathematical what? Formulas directly now. And also this is actually capable. You can see it now. This is how it actually works now. So this TensorFlow now allows us to express what? Mathematical formulas directly now. So this capability is what enable it to what? To power neural what? Network and what? An optimization algorithm. So machine learning model now are not just what? Mathematical functions under the what? Under the hood. Now the next thing we'll look at is what? Is the gradient computation now. So what this gradient computation actually does is that it introduces what? Automatic differentiation. Now which is the art of what? Deep learning. So let's actually see some example under it now. I will now come here. First thing I will be doing now. Now first of all what? Import my TensorFlow. Import TensorFlow now as what? As tf. Now I'll come here now. I will now say x equals what? Equals tf. That's TensorFlow dot what? Dot variable. Now the variable I'm using is what? 3.0. Variable open parenthesis 3.0. Now close this parenthesis. I'll hit on enter. I will now come here and I'll say with what? tf dot what? Dot gradient. Now tape open parenthesis close parenthesis. I'll give it an alias of what? Of tape. I'll hit on double column. I'll hit on enter. Now I'll bring up my y now. Y should equals what? X. Now multiply by 2. Now I will now hit on enter. I'll come here and I'll bring up the what? The dy dx. The y underscore dx. Now equals what? Tape dot what? Gradient. Now open parenthesis y comma x close parenthesis. I will now print now. Print open parenthesis dy underscore what? Dx close parenthesis. Let's run this now. Control enter. Let's wait for it to come up. Now ignore the warning. So this is it now. We have what 6.0, and we have the shape and the what and the data type. Now which to be what to be float 32. Now this is one of the what one of the TensorFlow most powerful features. Now this gradient tape, now what it does is that it automatically calculate what our derivative. What's our derivative now? The derivative is what they divide the x now, so which are required to train what neural network. Now without gradients, now learning without now without the gradients, now our learning will not be what will not be possible. Now let's see another example. Let's say with what tf now dot what dot gradient tape, open parenthesis, close parenthesis, give it an alias of what of tape. Now double column, hit on enter. I'll now say w now should equals what equals tf now dot variable open parenthesis 3.0. Now close this parenthesis. I'll hit on enter. Now for the x, now let's say x equals what tf now dot constant. This is constant. Now open parenthesis, let our constant be 2.0, close this parenthesis. Now for our y, now y equals what now w now multiply by x. So let me bring my cursor down. So w multiplied by x. Now I will now hit on enter. I'll come back here. I'll now say gradient now equals what equals tape now dot what dot gradient open parenthesis. That's y comma what comma w. That's how we bring it out. Now print. Now let me bring my cursor down again. So to print it now, I'll print this what this gradient. So everything here represents the gradient. So I will now print this what this gradient. Print open parenthesis gradient. Now close this parenthesis, control enter. So you can see now. So this is the shape, and this is the what this is the tensor, and this is the what data type. Now like I said earlier, now the gradient tape now record what operations now, and also automatically compute our derivative. It's just like the foundation of what backward propagation now. So that is it now. So in deep learning now, it is the art of the deep learning now. TensorFlow what calculate the derivative, so we don't have to what do that ourselves. Now the next one we'll be looking at is what building a model. So that means we are not actually training yet. What I mean by that is that we are not making use of a data set yet. So what we are doing now is what showing model structure without what focusing on data set. That means we are trying to defining a what that means we are defining a neural network architecture without data. So let's see how it actually works now. Now to do that, now I will now say from TensorFlow, now import keras. Now hit on enter. I'll bring up my model now. Model now equals what keras now dot sequential. Now open this parenthesis. Now bring up this list. I'll hit on enter. Now I'll now say keras dot what dot layers now dot dense. Now open parenthesis. Now I'll now say 16 comma what activation equals what a single quote relu. Close this single quote, put a comma. Now I will now say input underscore what underscore shape now equals what, open parenthesis, now 4 comma, close these two parentheses, put a comma. Now I will now hit on enter. Now say keras now dot layers dot dense. Now open parenthesis 1, close parenthesis, I'll hit on enter. I'll close this list. I'll now close this second parenthesis. Now I'll hit on enter. Now so I want to actually what, define this now. To print it now, I'll now say model dot what dot summary. Now open parenthesis, close parenthesis, control enter. So let's see what we have now. Now let me bring my cursor down a bit better now, so we can see everything now. Now what we actually did here now, this model actually structured the what, model structure now. Now this model structure is actually what, independent of data. And the layers now, these layers that you are actually seeing now, define how information actually flows. For this summary now it shows the what, the architecture of what we actually did. So just ignore the warning. So the model is sequential, and this is the layer of it, this is the output shape, and this is the what, this is the parameter. So let me scroll down now and see now. Let's scroll down. So you can see the total numbers of the parameters, and the trainable parameters and the non-trainable parameters. Now what this actually means is that we built a complete neural what, network without a single what, data set now. So this is the structure before what, before learning. Now the learning I'm actually referring to is what, is the machine learning. Now the next thing we'll look at is what, is the loss function. Now this loss function now, this loss actually measures how wrong what our predictions are. So that's what it actually does. Now to bring it up now, I will now say loss underscore what, fn, that's the function, loss function, equals what, keras now dot what, dot losses dot mean squared now error, open parenthesis, close parenthesis. You can see now we are still yet what, using data set. Now we'll now say y underscore what, underscore true now equals what, tf, now that's the TensorFlow dot what, constant. Now open this parenthesis, bring up this list. Now I will now say 3.0, close this list, close this parenthesis, hit on enter. Now the next one now say y, that's the true underscore what, prediction now equals what, now tf dot what, dot constant. Now open this parenthesis, bring up this list. Now that will now be 2.5. now close this list, now close this parenthesis. I will now hit on enter. Let me bring my cursor down now so that we can see everything perfectly well. Let me bring it up a bit. Now let's continue. So the next thing, now hit on enter. Now say loss now equals what, loss underscore what, underscore function. Now open parenthesis, y underscore what, underscore true underscore true. Now put a comma, y underscore what, underscore print. Now close this. Now let's print this. Now print, what are we printing? We'll print the loss now, loss. Now close this. Let's run this now, control enter. Oh, we got an error. The error is, oh, there was a typographical error. Now let me bring my cursor up, and there's here now, there's not supposed to be y again. Now let's reprint this now, control enter. So you can see it now, it's working perfectly well. Now what this loss function actually does is that it compare predicted and actual values now. So And also it actually guides the what, the learning what process now. So once it actually compare the predicted and what actual value, it also guide the what, the learning process. So loss is like, let me give a scenario of it now. Loss is the what, teacher of the model. So without loss now, learning cannot actually what happen. Last one we'll be looking at is what, is the optimizer what concept. Now we are still here to use what, data set now. So what this optimizer actually does is that, so optimizer updates what variables to actually reduce what loss for us. Now let's see how it actually work now. So we are trying to use it without it. All these ones are just a demo of how it actually works. Now optimizer now equals what, keras now dot what, optimizer dot what, sgg now open parenthesis learning underscore what, underscore rate now equals what, 0 point what, 0.1. now close this parenthesis, hit on enter. Now hit on enter again. The next one now say variable equals what, tf. Now that's the tensorflow dot what, variable. Now the variable I'm using here is 10.0. Don't forget, I once mentioned it that what variable can actually what, change. Now optimizer, now bring up my optimizer dot what, dot apply underscore what, gradient. Now open parenthesis, bring up this list, bring up this parenthesis. I'll now say tf now dot what, dot constant. Now open parenthesis 1.0. now that's the constant, close the parenthesis, put a comma. Now say variable. Now close this first parenthesis followed by this list. I'll now close this last parenthesis that we opened first. Now I'll print. Now what am I printing? I'll print this variable now. Print open parenthesis var. Now close this parenthesis. Let's print this now. Control enter. So you can see it now. The variable is what, 0. This is the shape, this is the data type, and this is what, this is the numpy. Now optimizer actually does here is that optimizer changes what, variables, and also move what, values towards what, minimum loss. Now the optimizer controls how fast and how well a model actually what, learn. Now let's see more example on it now so that we can get a better understanding about it. Now let's see this example now. This example is talking about what, gradient of a simple what, quadratic what, function. Now so this will show how what, TensorFlow compute what, the rate of change of a function automatically. Now let's say import TensorFlow as what, as tf. Don't forget. Now let's see our x is what, x equals what, tensorflow dot variable. Let's say the variable is what, open parenthesis, let's say 5.0. now close this parenthesis, hit on enter. Now come here and say what, with tensorflow dot what, dot gradient. We are talking about gradient tape. Now open parenthesis, close parenthesis, give it an alias of what, of tape. Give it double column here, hit on enter. Now I'll now bring up my y now. Y equals what, tensorflow dot what, dot square. We've done this kind of example earlier, so I will now emphasize more on it now, because some people may be surprised that how do we arrive at the value. Now plus what, plus 2. now multiply by, that's shift 8, multiply by x plus, let's say plus what, plus 1. You can actually change the value anytime. Now let's look at this what, quadratic function now. So we said what? TF dot what? Dot what square of what? Of x. Now in mathematics, now if we want to actually write this, now that will now be x square plus 2x. You know we said what? 2 multiplied by what? By x. That will now be x square plus 2x plus 1. So that is how the what? The in quadratic equation will actually be, or quadratic function now. But in what? In you making use of the TensorFlow now, we write it as what? TF, that's the TensorFlow dot what? Dot square of what? Of this x plus 2, now multiply by what? X plus 1. Now let's actually what? Solve this now. To now solve this, I will now hit on enter. I will now come here and say dy underscore dx. Dy dx now equals what? Tape now dot what? Dot gradient. Dot gradient open parenthesis. What are our gradient now? That's the y now and x. Now close this parenthesis. Print now. Print open parenthesis. What are we printing now? That's the y underscore what? The x. Close this parenthesis. Let's print this now. Control enter. Now look at the value we actually got. Now we got 12. And see the tensor now. The TensorFlow actually watches x and record all the what? Operation. Also compute what? The derivative with what? With respect to this what? To the value of this x. Now, so we didn't calculate the derivative ourselves now. The TensorFlow actually did it for us. So, and it was actually accurate and what? Instantly. So that's how it actually works. Now let's see another example now. Another example, let's say now what we'll be looking at is what? Gradient of a cubic what? Function now. This actually shows that what? Gradient what? Tape works with more what? Complex equation. Now let's actually see example under this now. I will now come here and now say x equals what? TensorFlow dot what? Dot variable. Now what's the variable I want to use? Let's say 3.0. Close this parenthesis, hit on enter. I will now say with TensorFlow dot what? Dot gradient tape now. Gradient tape now. Open parenthesis, close parenthesis. I'll give it an alias of what? Of tape. Now give it double colon, hit on enter. Now say I'll bring up the y now equals what? TensorFlow now dot what? Dot power. Now open parenthesis x comma what? Comma 3, close this parenthesis, plus 4. Now multiply by what? X. Now what this actually means is that what? X multiplied by what? 3. Sorry, power of what? Of x. Now that means x raised to power 3. Now 3 multiplied by x raised to power 3, that will now be 3x, plus 4 multiplied by x, that's 4x. That's what this actually means. Now when we now make use of what? Dy dx, now that will now be dy underscore dx. Now this will actually now change to what? So because x can now divide both sides now, so like what we have, this is a mathematical what? Function now. So x can divide both sides. Once x divide both sides now, so this will now return back to what? Ordinary 4. It will no longer be 4x, and this will now be out of the power now. One of the x will actually go, so it will now be 3x raised to power of what? Of 2. So that's what we actually have. So let's come back here. Let me now say dy underscore what? Dx now equals what? Tape dot what? Dot gradient. Dot gradient open parenthesis. What's our gradient now? That's y comma x. Now close this parenthesis. Now I will now print. Now print. Now open parenthesis dy underscore what? Underscore dx. Now close this parenthesis. Now let's run this now. So the value we'll be getting is that since s is what? 3.0, we'll be getting 31. Let's run it. Control enter. So you can see it now. Now the gradient tape now actually handles the what? The binomial. Now the gradient tape now, you can see now it actually handles the what? The polynomial of any degree. Now this is why it actually scales to what? Deep network. So that's how it actually works now. So you can see it now. It's just like we are solving a what? Real mathematics now. Now let's see gradient with multiple variable. Let's see how we can actually do it with multiple variable now. Now gradient with multiple now. Let's say, oh, I didn't put. multiple variable. Now what this actually does is that this multiple what variable, now it shows how what TensorFlow can handle more than what one variable. Now let's see it. Now I will now come here, let's say x equals what TensorFlow dot what variable. Now open parenthesis, let's say 2.0. Now close this parenthesis, hit on enter. Let's say w this time around, let's say equals what TensorFlow again. Now dot what dot variable. Now open parenthesis 4.0, close this parenthesis. Now hit on enter. I'll now say with TensorFlow dot what dot gradient. Now gradient tape, open parenthesis, close parenthesis. I'll give it an alias of what of tape. Now I'll hit on enter. Let me bring my cursor down. So I'll now come here, I'll hit on enter like I said earlier. Now so I'll bring up the function. Now that will now be y equals what w. Now multiply by what TensorFlow dot what dot square, open parenthesis x. Now close this parenthesis. Now I will now hit on enter. Now when I hit on enter, I'll come back here and say what grades now equals what that's tape dot what gradient, open parenthesis. Now y comma what comma, I'll bring up this list now. So the gradient will now be x now comma what w, close this list, close this parenthesis. I'll hit on enter. I will now print. Now print. Now open this what parenthesis. I will now print what gradient. Now the grades. I'll close this parenthesis. Now what we actually did here, now that's what we said y equals what now w multiplied by what TensorFlow square. Now square of what of s. Now that means w multiplied by s square. That means y equals what w multiplied by s square. That's y equals ws square. Now so if you bring up your what dy dx now, so that will now be what was our x. Our x is 2.0, so that will now be 2 what 2wx equals what 16. So if you divide both sides, now that will now be s square equals what equals 4. So let's actually run this now. That's what we'll actually get. Control enter. So you can see it now. You can see what we actually got. So you can see it now. This is just like a neural network. It have what many parameters now. So the TensorFlow can compute the gradient for all of them at what at once. So that's how we actually have for this. So you can see 4.0 and 16.0. Now the next one we are looking at is what gradient of a loss function. Now what this gradient of a loss function actually does is that it connects the gradient to a what to a model learning. Now let's actually see how to do that now. To do that now say y underscore what underscore true now equals what TensorFlow dot what dot constant. We'll make use of constant here. Now open this parenthesis, let's say 10.0. Now close this parenthesis, hit on enter. Let's bring up what w. Now equals what now TensorFlow dot variable now open this parenthesis. For this now let's use 2.0. now close this parenthesis. I'll hit on enter. I'll now say with TensorFlow dot what grade. Now I'll now say gradient tape. Now open parenthesis, close parenthesis, and give it an alias of what of tape. Now I will now say double column. I'll hit on enter. So I'll now say y underscore what predict now equals what w now multiply by 4. Now hit on enter. For the loss now let's say equals what TensorFlow dot square now open parenthesis y underscore what underscore true now minus what y underscore what, underscore predict. Now close this now. So let's determine let me bring my cursor down now. Let's determine the loss now. I'll now come here, hit on enter. I'll come back here. I'll now say d loss underscore what, dw. Now let me hit on enter. Okay, underscore dw. Now equals what, TensorFlow dot what dot gradient. Now open parenthesis loss. Now comma w, close this parenthesis. Let's print this now. Print. What are we printing now? Open parenthesis d loss underscore what, dw. So close this now. It's just like we are saying what, we are making use of the dy dx. Now, so we make prediction here and we make error here, and we determine our what, loss here. We determine prediction, we determine error, and we determine what, loss. So let's actually run this now. Control enter. So sorry about that, we got an error. This should be tape, not TensorFlow again. That was a typographical error. Let's run this now. Control enter. So this is what we are supposed to get now. Now if you look at what we this is what value for the tensor now, TensorFlow now. Now if you look at what we actually did here now, we said for the prediction now, we said y underscore what, true, now minus what, y underscore what, the prediction now. With that is what our y is what now, the value of w is what, 2.0. now if you put 2.0 here now, that will give us 8. Now if you bring that 8 here now, so what's the value of y underscore true now? That's 10. 10 minus what, 8 is what, is 2. And for the loss now, the loss is actually what, 2 raised to power what, 2 raised to power 2. That's equals what, 4. So that's how we get all these values now. So this is the total value of everything now. This is exactly what happened during what, during training now. So the model will learn by what, reducing loss for us. Now let's actually see another example now. This time around, let's see manual gradient what, descent. Now let's see how we can actually do that. Now what this actually does is that it actually show how what, learning actually update what, weight. Now this should be A, not E. Let me correct this now. Now let's run this now. So let's see an example under it now. Let's say learning underscore what, underscore rate now equals what, 0.1. Now hit on enter. Now for the w now, let's say that's the weight, now equals what, TensorFlow dot what dot variable now open parenthesis 2.0. now close this parenthesis. Now hit on enter. I will now say width TensorFlow dot what dot gradient tape now. Now open this parenthesis, close this parenthesis. I'll give it an alias of what, of tape. Now double column, I'll hit on enter. I'll now say loss equals what, TensorFlow dot what dot square open parenthesis. Now what's the square now? That's 10 minus what, 10 minus w multiplied by what, multiplied by 4. So let me just, okay, now that's the loss. Now let me bring my cursor down so that we can see everything. Now let's continue. So I will now hit on enter. I will now come back here. Now I'll now say grid equals what, tape now dot what dot gradient. Now open parenthesis, that will now be loss comma what, comma weight. Close this now, hit on enter. I'll bring up the what, the weight now, and I'll say weight assign underscore what, underscore sub. Now open parenthesis, learning underscore what, underscore rate. Now dot multiply by what, multiply by grade. Close this parenthesis. Now let's print this what, this weight now. Print open parenthesis the w, close this now, control enter. Sorry, there was a typographical error. This should be dot, not what greater than sign. Now let's reprint this now. Control enter. Now you can see now this is the variable and this is the shape, this is the numpy and this is the what, the d type. Now so the gradient, it tells what, the direction, the learning rate controls the what, the step size, and the weight move towards what, better value. So it's just like we are optimizing what. So you can see it now, the optimizer what up. Now you can see it now, the optimizers up. Now you can see it now, the optimizers what, automate this step now. Now the next one we'll look at is what, is the gradient tape with what, with tensor. Now in case of what, in a case of vector. Now what this actually shows is that it actually shows how TensorFlow handles what, vector what, input. We've actually seen example of vector, scalar and what, and matrix earlier when we started. Now let's actually see how it works here. Now let's say x equals what, equals TensorFlow dot what, dot variable. Now upon this parenthesis, we bring up a list now of a vector. Now that will now be 1.0. Let me use 1.0 comma, now 2.0 comma, now 3.0. Now I'll close this list, I'll close this parenthesis. Now I will now hit on enter and I'll say with TensorFlow dot what, dot gradient tape. Now open this parenthesis, close this parenthesis. I'll give it an alias of what, of tape. Now give it double column, hit on enter. I'll now say y equals what, TensorFlow now dot reduce. Now reduce what, underscore sum. Open this parenthesis. Now TensorFlow dot what, dot square. Now open this parenthesis. Now x, close this parenthesis. I'll hit on enter. I'll come back here. Now let me bring my cursor down. Now I'll come back here. I'll now say now grade now equals what, tape dot what, dot gradient. Open parenthesis y comma what, comma x. Now I'll print. Now print, open parenthesis, the grade, close it, control enter. So you can see it now. Now you will be surprised of how do we arrive at this what, these values. Now so what we actually have here now, that's what it will actually work along with what, with our what, our gradient. Now so we said the variables is 1.0, 2.0 and 3.0. Now and the gradient is what, our gradient is, what do we have for the gradient? So that's what, 2, 4 and 6. So that's for the gradient. Now you'll be surprised, how did I get what, how did I get the gradient 2 comma 4 comma and 6 comma. Now this is the gradient. Now that's, we said sum here. Now that's 1.0 plus 1.0, that's 2.0, 2.0 plus 2.0, that's 4.0, 3.0 plus 3.0, that's 6. So that's how we got the gradient. So this is why TensorFlow works for what, images, text and what, and time series, because everything becomes vector and what, and gradient to it. Now like the example I actually emphasize on that, how we got the gradient and the what, and the vectors values now that I made mention. Now let me did one example. Now let's say tensor with multiple values. Now let's bring up the, let's say, let's come here and say import TensorFlow as what, as tf. Hit on enter. I'll now say x equals what, x equals tf dot what, dot constant. Now open this list, open this what, open this parenthesis, open this list. Now say 1.0. I want to use 1.0 comma 2.0 comma, now 3.0. Let me put space in between all of them. Now comma 4.0. Now I will close this list, close this parenthesis. Now I will now hit on enter. For the y, now the y equals what, TensorFlow dot what, dot square. Now, now hit on enter. Now for the y now say equals what? TensorFlow dot what dot square. Now open parenthesis x, close this parenthesis. Now say plus what? Plus 2. Now multiply by x. Now plus 1. So if you want to print y now, so let me actually emphasize on this now. So if you want to print y now, so how do we get this value? Now let's print y and let's see something now. Open parenthesis y. Now close this, control enter. So this is how we got the what? The value of y. Now let me now explain it now. Our x is what? 1, 2, 3, and 4. So this will now be what? 1 square, 2 square, 3 square, 4 square. That's for the x. So that's how we got what? 1, 4, 9, and 16. That's for it now. Multiply by 2. Multiply by 2. That is what? 2 multiplied by 1. That is what it will now be now. 2 multiplied by 2. 2 multiplied by 3. 2 multiplied by 4. So that's the value we will now get now. That will now be 2, 4, 6, and 8. Now add this plus 1 to it now. We now said what? Multiply by what? Value of x now. Multiply by plus 2. That will now be what? 2 multiplied by what? 1. 2 multiplied by 2. And 2 multiplied by 3. 2 multiplied by 4. So after that now we will now get what? 2, 4, 6, 8. Now we now said plus 1. So plus 1 to the value of what? Of this x now. That will now be 1 plus 2 plus 1. That's for this now. This one will now be what? 4 plus 4 plus 1. The next one will now be what? 9 plus 6 plus 1. And the last one will now be 16 plus 8 plus 1. So you'll be surprised. Don't be surprised the way we got those values now. We first of all get the square. So square of 1 is what? Is still 1. And square of 1 is still 1. Now plus 2. This 2 that is here, that makes it 3. Plus this one that is here, that makes it what? 4. And the next one is what? The square of it is 4. 4 plus what? 4 plus 4. So 4 plus 4 plus 1 that we have here. And the next one is now what? Square of 3 is what? Is 9. 9 plus what? Plus 6 plus 1 that we have here. That's how we got what? 16. And the next one, the last one that we got here was what? 16. And square of 4 is what? 16 plus 8. Now plus 8 plus 1. So that's 25. So that's how we got what? 4, 9, 16, and what? And 25. The shape is now what? 4. And the data type is what? Is float. So that is it. So you can see the what? The TensorFlow did not just what? Use a loop. It automatically applied the same formula to every values inside our what? Inside our tensor. So this is what they actually called what? Vectorization. And it is one of the what? The reason TensorFlow is extremely what? Fast. Now let's see some example under this what? Metric what? Tensor. How data enters a what? A neural network. Now what this actually focus more is that what? Metric tensor. That's the what? That's the 2D tensor. And what? And for the row now, that's the data record. For the column, that's the fixtures. And how neural network what? How neural networks work. Now let's see. Now I will now come here, or how it actually see data. Let's say import TensorFlow as what? As tensor. That's TF. Now, so the matrix tensor. Now let's use 3 rows 2 fixtures now. Now what do I mean by 3 rows 2 fixtures? Now let's say x equals what? TensorFlow dot what? Dot constant. Now open this parenthesis followed by this list. Hit on enter. I'll bring up this list now. Now say 1.0. Now comma. Now 2.0. Now close this parenthesis. Then close this list. Now put a comma. Hit on enter. Now let's bring up this list again. Let's say 3.0. Now comma. The next one, that's 4.0. Close this list now. Put a comma. Hit on enter. Now the next one is what? Open this list, 5.0. Now put a comma, 6.0. Now close this list. Now I will now close this parenthesis that we opened earlier, the list first followed by the parenthesis. Now hit on enter. I will now say y equals what? Equals TensorFlow dot what? Dot square. TensorFlow dot square, open parenthesis, square of what? X, close parenthesis, plus, that's the equation now, plus 2 multiplied by x, now plus what? Plus 1. So let's print our y now and let's see our value. That will now be print, open parenthesis, y, now close parenthesis, control enter. So let me bring my cursor down and let's see what we have. Let me move it up gently. Now you can see it now. So this is what it has actually what become. Now that's rows. Now that's the individual data point. The columns is now the what? Is the fixtures. So this is exactly how data sets are fed into what? Neural network. Don't forget this x is our what? Is our matrix what? Is our metric tensor. Now this is how we got these values now. 1 square, that's 1. Now 2 square, that's 4. 3 square, that's 9. 4 square, that's 16. 5 square, that's 25. And 6 square, that's what? 36. So that will now be what? Once you want to bring it out now, 1 square is what? Is 1. And 2 square is what? Is 4. So that will now be what? 1 comma 4. Now the next one will now be be 9 comma 16, 25 comma what? 36. That's when you first of all get the square of everything that we have here. Now after that, you now multiply each element, each of those elements. That's 1 comma 4, 9 comma 6, and what? So you multiply each of them now with what? By 2. So once you multiply by 2 now, that will now be plus 1 that we have here now. So what is our plus 1 now? That will now be 1 plus 2 plus 1. That's for what? When we add what? Including the elements. The next one will now be 4 plus 4 plus 1. Now the next one will now be 9 plus 6 plus 1. The next one will now be 16 plus 8 plus 1. The next one will now be 25 plus 10 plus 1. And this will now be what? 36 plus 12 plus 1. So after that, now we will now get what? 4. Now we will now 4 plus 4 plus 1, that's 9. 16 now, that's 9 plus 6 plus 1. And for the 25 now, that's 16 plus 8 plus 1. And for this now, that will now be 25 plus 10 plus 1. And 49 is what? 36 plus 12 plus 1. Please kindly take note of how we are actually arriving at those what? Those values. So our shape is now 3 comma 2, and this is our data type now. Now let's see another example. Let's say what? TensorFlow what? Variable. Now let's say import what? TensorFlow as what? As TF. I'll hit on enter. Now let's bring up a what? A trainable parameter now. That will now be w equals what? Now TF dot what? Dot variable. Open this parenthesis. Let's say 3.0. Close this, hit on enter. Let's bring up b now. So let's say TensorFlow dot what? Variable again. Now open parenthesis, that's 2.0. Close this parenthesis. Now let's input our value now. That will now be x equals what? TensorFlow dot what? Dot constant. Now open parenthesis, let me give it 5.0. Close this now. Now for our linear equation now, that will now be y what? Equals what? Let's say wx plus what? Plus b. Wx plus b. Now to print your y now, let me bring my cursor down. Let's print our y. Let's see the value of y. Print, open parenthesis, y, close this, enter. So sorry about that. Now so you can see it now. That's 17 point what? 17.0, because the value of your w is 3 and the value of our b is what? Is 2, and the value of x is what? Is 5. So that's what? W multiplied by x plus b. Now that's 3 multiplied by 5 plus 2. So that's 15 plus 2, that's 17. That's how we got the value of this what? This 17 that you are seeing here. So that's it now. So the constant represent the what? The data. The variables represent what the model learn. Take note now. The constants represent what? Data, while variables represent what the model learn. So during training now, TensorFlow keep adjusting our what? Our W and B until predictions becomes what? Accurate. Now we've actually talked about automatic word differentiation before. So how TensorFlow actually learn what a loss function is, how the TensorFlow calculate the gradient, why the why gradient tape is essential. So let's just see an example under it again. So to see an example under this what? Under this automatic differentiation again now, let's come here and say import tensor TensorFlow as what? As TF, hit on enter, come here. Now our trainable variable now say W equals what? Now TF dot what? Dot variable open parenthesis, let's say 3.0, close this parenthesis now. Now for the B now, let's say equals what? TF dot what? Variable, now open parenthesis 2.0, close this parenthesis. Now I will now import and what? And true output. Now that will now be x equals what? TensorFlow dot what? Dot constant open parenthesis, now 5.0, close this parenthesis, hit on enter. I'll now say y underscore what? Underscore true. Now equals what? TensorFlow dot constant open parenthesis 20.0, close this parenthesis. Now I will now hit on enter. I will now say with what? TF dot what? Gradient tape. Now open parenthesis, close parenthesis. I will now give it an alias of tape, don't forget. Now double column, I'll hit on enter. Now I'll bring up my word prediction, y underscore predict equals what? W. Now W multiply by that shift 8 multiply by x plus b. Now for the loss equals what? TensorFlow dot what? Dot square open parenthesis y underscore what? Underscore predict. Now minus what? Y underscore true. Now close this. Now the next thing, now I will now compute the what? The gradient. I'll come back here and I'll say dw comma db now equals what? Tape. Now dot what? Dot gradient open parenthesis loss comma, now bring up this list w comma b. Now close this list. Now close this parenthesis. I will now hit on enter. I will now print. Now print open parenthesis double quotes, now loss, now double column, close double quotes, comma. I will now say loss. Now close this. That's for the loss. Let's print loss first. Control enter. So this is the loss now. So let's print the gradient now. The gradient, that will now be what? Print open parenthesis, now double quote, gradient, now w dot what? R dot what? Dot t. Now w double column double quote, and now say dw. Close this. Now control enter. Oh, we got an error. I didn't close this what? Double quote. Now there should be a comma here before this. Now let's run this. Now control enter. So okay, sorry about that. Now let's print the last one. Now print open parenthesis double quote, gradient, now w dot what? dot r dot t. Now b double column, that's for the b. Now close double quote. If we actually print for the what, for the weight, this is for the weight. Now I'll now say comma again, db. Now close this. Now control enter. So that is it. Now so if you look at what we actually have now, we said y underscore what, underscore predict equals what, w multiplied by x multiplied by x plus b. And we said y underscore what, y underscore predict. Now that will now be what, what's our w? Our w is what, is 3 multiplied by 5 plus what, plus 2. That's how we got this what, this 17. And for this now, we said loss. Now square, don't forget loss. This means what, y underscore predict, y underscore true. That means the prediction minus the actual value. Now what's our prediction? Now our prediction is what, 17. Our actual value is what, is 20. So don't forget we still have square, because tf dot square, that means everything here should be squared. Now that's now 17 minus 20 raised to power 2. Now 17 minus 20, that's minus 3 raised to power 2. That's minus 3 minus 3 minus 3 multiplied by minus 3, that's 9. So that's what we actually got, this what, 9.0. So take note of that. So what this what gradient step actually does is that it record what, every mathematics what operation. Now so it allows TensorFlow to compute derivative what, automatically. Now that's for this. Now so it actually tells us also, this gradient also tells us how much each variable change to reduce the loss. Now so look at this dw. Now let's come to this dw. Now so we said dw, let's come here. Now multiply by y underscore what, underscore true minus what, and y underscore prediction underscore true multiply by x. So that's what we actually have now. So to bring and to get this value, how we got this 30? Now that will now be 2 multiplied by what was our minus, and what's our prediction? Now our prediction is minus 3 and our true is what, 30. That's 2 multiplied by minus 3 multiplied by 5. So that's how we got this what, minus 30. And for this b now, so that's what, 2 multiplied by, what's our prediction? Now our prediction is what, minus 3. After we subtract prediction from true, now that means from actual, so we got what, minus 3. That's 2 multiplied by minus 3 now equals what, this 2 here multiplied by minus 3, that's minus 6. That's minus 6.0. That's how we got what, it. So the loss is 9.0. The gradient and weight is what, is minus 30, and the b is what, is 6.0. So it doesn't guess. TensorFlow does not guess how to learn. It uses what, calculus to decide how much to adjust what, each parameter to reduce error. Now let's see an example now, based on the optimizer. Now how the TensorFlow updates weight automatically. Now let me bring my cursor down. So I'm trying to what, I'm trying to bring up several examples so that we can get it perfectly well. Now so let's say import TensorFlow as what, as tf. Now hit on enter, come here. So our trainable what, variables. Now that will now be w equals what, TensorFlow dot what, dot variable. Now dot variable. Now open parenthesis 3.0. Now close this parenthesis. Now so that when we apply it to a real life scenario, now we will know how all these things actually work. Now so I will now say b equals what, now TensorFlow dot what, dot variable. Now open parenthesis 2.0, close this. Now hit on enter. Let's say x equals what, TensorFlow dot what, dot constant. Now open this parenthesis 5.0, close this. Now hit on enter. I will now say y underscore what, underscore true. Now equals what, TensorFlow dot what, dot constant. Now open parenthesis 20 point what point 0, close this parenthesis. Now for the optimizer, now I'll now say optimizer now equals what, equals TensorFlow dot what dot keras dot what optimizers dot sgd. Now open parenthesis learning underscore what underscore rate. Now equals 0 point what 0.1, let's say 0.01. Now close this. Now I will now come down here and now say with TensorFlow dot what dot gradient tape now open parenthesis, close parenthesis. I'll give it an alias of what of tape. Now say double column, I'll hit on enter. I'll now say y underscore what predict now equals what w now multiply by what multiply by x now plus what plus b. So I'll hit on enter. Now for the loss, I'll now say equals what TensorFlow dot what dot square open parenthesis y underscore what predict now minus y underscore what underscore true, close this parenthesis. Now let's compute the what the gradient. Now to compute the gradient, I will now hit on enter. Now say grade equals what tape now dot gradient open parenthesis loss now comma. Now bring up this list, that's w comma what comma b, close this list, close this parenthesis, hit on enter. Now I will now update these variables. Now say optimizer dot what apply underscore what gradient underscore gradient. Now open this parenthesis, let's say zip open parenthesis grades. Now what are our grade? Now bring up this list, that's w comma what b. Now close this list, close this parenthesis. Now I will now be printing. Now one of now print open parenthesis double quote updated what w now double column close double quote, put a comma, that will now be w dot what numpy open parenthesis, close parenthesis. Now close this parenthesis. Now let me bring it here. Now control enter. So let's see, we got an error. Let's see the error. Okay, this was never closed, so let's close that parenthesis. Now I have closed this now, so let's run it now. Control enter. So we got our what our updated what weight now, which is 3.3. So let's see the updated, let's go up a bit. Now let's see the updated loss and the bias now, which is the b. Print now open parenthesis double quote now updated b now double column close double quote. Now put a comma. I'll now say b dot what numpy open parenthesis close parenthesis. I'll now print this. Now control enter. So let's see the last one. So print open parenthesis double quote loss now close and double column double quote comma, that will now be loss dot what dot numpy. Now open parenthesis close parenthesis, close this parenthesis, control enter. So let's see everything together now. So this is what updated weight, updated bias, and updated loss. Now the next one, let's see training loop. Now let's see how we can learn what over multiple steps. Now that's where we'll training many what steps That's like epoch. So watching loss reduce and understanding the what the the convergence, the and understanding the convergence. Now let me just copy this so that it won't take much of our time. Let me just copy this. Now let me just copy from here. Now to this optimizer. So we'll just start from this optimizer. Let me copy it now. Let me come down here and let me paste this. Now the next thing now, the loop now, training the loop now. That now before step in what? In range. For step in range, open parenthesis 10, close this now. Let's say double column. Now hit on enter. Now say with TensorFlow dot what dot gradient tape. Gradient tape. Now open parenthesis, close it, give it an alias of what? Tape. Now close double column, hit on enter. This should be, let me delete this. Now let me come back here. Now hit on enter. That will now be y underscore what? Prediction. Now equals what? W multiplied by what? Multiplied by x plus b. Now hit on enter. For the loss now, that will now be equals what? TensorFlow dot what? Dot square. Now open parenthesis y underscore prediction minus y underscore what? Underscore true. That's the actual. Don't forget. Now hit on enter. Come back here. That will now be grade equals what? Tape what? Let me hit on enter. Tape dot gradient, open parenthesis loss. Now comma, open this list. That will now be comma b. Close this list, close this parenthesis. I'll hit on enter. Optimizer dot apply underscore what? Underscore gradient. Now open this parenthesis, zip. Now open this what? This parenthesis. That will be grades. Now put a comma. Bring up this list now. That will be w comma what? Comma b. Now close this list, close these two parentheses. Now let me bring my cursor down. So let's continue now. The next thing, to print it now, that will now be, let me hit on enter. Now say print, open parenthesis, f string. Now step, let's say step. Now I'll bring out this nested JSON symbol. Now say step plus 1. Step plus 1. Now close this nested JSON symbol, double column. That will now be w equals what? Now this nested JSON symbol again. That will now be w dot numpy, open parenthesis, close parenthesis, double column. Now dot 4f. Now close this nested JSON, put a comma. Now say b equals what? B equals this nested JSON. That's for the bias now. That's b dot what? Numpy, open parenthesis, close parenthesis, double column. Now dot what? Dot 4 what? 4f. Now close this nested JSON again. Now put a comma for the loss. Now loss equals what? The same thing again. I'll bring up this. Now loss dot what? Numpy. Now numpy, open parenthesis, close parenthesis, double colon. Now say dot 4 again, 4f. Now close this nested gemstone, close double quote, close this parenthesis. Now let's run this now. Control enter. Let's see what we have. We got an error. So range, the name range is not defined. Let's rectify that now. That is here. Now I've rectified it. Now let's rerun this. Control enter. So we got our values now. So you can see it now. This is step 1, step 2. So this is the step that we are actually saying here now. Step 1, step 2. Let me bring the cursor down a bit. Step 1, step 2, step 3, step 4, step 5, step 6, step 7, step 8, step 9, and step 10. Now, the reason why we actually use a loop is that so learning does not just what happen once. Model improve what little by little. So each loop now equals what? One training step. So you can see step by step now. So that is how we actually what got those values now. So now the last example we'll see now. We want to actually build a simple neural network with keras. Now that's the next thing that we'll actually do now. So and we'll now round up this lesson. So let's build a simple building a simple neural network with keras. Now so this now let's say import, or let me just this is different. Import tensor flow as tf. Hit on enter. I'll now come back here and now say from TensorFlow import import keras. Hit on enter. Now for the simple neural network, now we'll now say that's model. That's what we will use. Model equals keras dot sequential. Now open this parenthesis. Now bring up this list. Now hit on enter. Now keras. Now dot layers dot dense. Now 1 comma. Now input underscore shape equals 1 comma. Now close this parenthesis. Now I will now hit on enter. I'll close this list, followed by this parenthesis. Now I'll hit on enter. Now say model dot compile. Now open this parenthesis, hit on enter. Optimizer now equals keras dot optimizers dot sgd open parenthesis learning underscore rate equals 0.01. Now close this parenthesis. Now put a comma, hit on enter. Now say loss equals double quote mse. Now close double quote, hit on enter, close this parenthesis. Now hit on enter. Now let's train the data. Now that will now be x now equals TensorFlow dot dot constant dot constant. Open this parenthesis. Now open these two lists. Let's say 5.0. Now close these two lists, close this parenthesis. Now hit on enter. Now I'll now say y equals what? TensorFlow dot what? Dot constant dot constant. Open parenthesis, open these two lists. Now say 20 point what? Point 0. Now close these two lists, close this parenthesis. I'll hit on enter. I'll now say model dot what? Dot fit. Now open parenthesis, x comma what comma y comma epoch equals what? 10. Now I'll now say fambos equals what? 1. Now close this. Now let's run this. Now control enter. So let's wait, just ignore the what? The error, and let's wait for it to actually come up. So you can see everything now. So now everything works perfectly well now. Now let me move my cursor up now. Let me emphasize on some things before we round up this lesson now. Now this sequential now, so is a model where layers are stacked one after the what? The other. So data flow from the what? From the top to the bottom in it now. So that's just like, let me give a scenario. So from the input to the dense what? Layer, from the dense layer to the what? To the output. Now what I mean by the dense now is that it has one neuron and internally contain what? The weight and the what? And the bias, which is the b that we are using. So for instance now we said what? W and y, our y equals what? W plus b. Now wx plus b now. So that is the neuron. That's what the neuron actually what? Compute now. So and for this now, model dot what? Comply now. Optimizer equals sgd now. This tell the TensorFlow how to what? This tell TensorFlow how to learn now. That means what is the TensorFlow learning now? The optimizer, and also how to measure errors, which is what? Which is the loss. And this now model dot what? Model dot fit that we actually have here now. X comma y and what? Epoch equals what? 10 now. So this now, this will what? Do the loss calculation, the gradient computation, and the width update for us. So that's how we have that what? Output we saw earlier. So that will be all for this lesson. See you in the next lesson. Do enjoy the rest of your day. Bye for now.